BYJU'S Exam Prep brings to you the second All India Open Mock from the 9th to the 18th of September. Go ahead, register now on the BYJU'S Exam Prep app and compete against thousands of aspirants.
Hi guys, a very good afternoon to all of you. I hope you had your lunch, not a very heavy one. We are having a session right now on modern maths for CAT exam. So let's first try to understand what constitutes this topic called modern math, and as usual I'm going to talk about how important is it, how many questions can be expected, and of course the bulk of the session today is about problem solving. So I hope you guys did not have a heavy lunch. I hope you're all ready with your pens and papers to solve few questions from modern math. So first, understanding modern math is a combination of 3 or 4 topics. The topics are, first is permutation and combination. Then you have, okay, let me just change the color. So P and C, you have probability, you have set theory or Venn diagrams. Set theory and Venn diagrams. Okay, so these are the areas that constitute the topic called modern math. Now, how important is it? Is it one of the important areas? How many questions can come? Let's take a look at what happened in the last 5 years. Based on, now I don't have the PPT slide in front of me, but I have this off my memory. Over the last 5 years, on an average, especially if you look at the last 2 years, all the 3 slots in both the years, totaling about 6 slots, the number of questions that have come from PNC, probability and set theory together is averaging around 1.5. At most 1.5, not even 2. Which means you can expect questions 1, maximum 2. That is what you can expect from PNC, probability and your Venn diagrams all combined. So yes, it is safe to say that it is not one of the most important topics. However, if you look at it for other exams like XAT averages around 3 to 4 questions from this area. So it is not so great when it comes to CAT, but when it comes to XAT, your NMAT and other exams, yes, this actually comes quite a bit. So depending upon what exam you are very seriously writing, you might want to choose to leave this or not. It's purely depends on what exam you're looking at. If you're looking at XAT very seriously, then I would say don't leave this. If you're looking at CAT, I would probably say go ahead with arithmetic, algebra, if time permits, geometry, and after that you might probably want to go for this. Right? So that's the whole idea. In fact, I would say number theory is a bit more important than this as far as CAT is concerned. Numbers averages around 2 to 2.5, which means it's a little bit more important than your modern math. Okay? Right. So what I'm going to do here now are questions from this topic. Unfortunately, this is not a session where I'm going to teach you the entire basics of PNC. This is practice of PNC, so I'm assuming that some basics are already with you, and I'm going to give you some different types of questions which will help you consolidate the basic ideas that you have in your mind. Right? Having said that, let's start off with the questions. But before I start, please give me likes on this video, guys. If you have not there on our channel yet, subscribe to our channel. We are there in Instagram, we are there in YouTube, and of course we have our BYJU'S Exam Prep app. Those of you who are seriously preparing for CAT, download the BYJU'S Exam Prep app. There is a live open All India mock. All India mock is free. It's available right now. It is live right now. It started on 9th. It will be available till 18th. So you have 2 more days if you discount today, 17th and 18th. The window closes on 18th. You will get All India rank. You will get All India percentile. You can see where you stand among the best of the competition, because our All India mocks are written by the students all over the country who are seriously preparing for the CAT exam. So you want to test yourself against the actual competition, write this particular mock and see where you stand. Right. So now let's go ahead and solve the questions. The questions coming your way. This is the first question, my friend. I'm going to give you 1.5 minutes to answer this. So 1 minute 30 seconds is a perfect time for you to answer this. Let's go ahead and see if you can get the answer. The time starts now. That's about a minute, another 30 seconds. All right, so that's about a minute and a half. This is not a difficult question, but the concept needs to be understood. The concept used here is called as dearrangement, D-E-A-R-R-A-N-G-E-M-E-N-T. So what is a dearrangement concept? So the dearrangement concept basically says if there are n letters and n envelopes, I don't know how you pronounce it. If there are n letters addressed to certain people and there are n addressed envelopes, the dearrangement concept says number of ways in which you can arrange the letters in the envelopes such that no letter goes correctly to the correct envelope. The number of ways in which you can arrange them in such a way that no letter goes correctly. This is given by a formula, and I'm going to write the formula here. N factorial into 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on up to 1 by n factorial. This is the formula for dearrangement. Once again, what is dearrangement? Dearrangement, basically arrangement is putting people in their respective places. Derangement is basically the reverse. You are putting people but not in their places. So the number of ways in which all the n letters will be going wrongly into n envelopes is given by this formula, n factorial into this entire thing. You can typically remember for 2 things going wrongly, 3 things going wrongly, 4 things going wrongly. These 3, if you remember, that will be good enough. You don't have to use the formula every time. But yes, if you are saying that there are just 2 letters and 2 envelopes and both the letters should go wrongly, there is only one way, correct? First letter will go to second envelope, second letter will go to the first envelope. Only one way in which it can happen. So 2 of them going wrongly is in one way. So next, if I have 3 envelopes and 3 letters, you can use the formula here, put n equal to 3 and see what happens. You will notice that if there are 3 envelopes and 3 letters, they can all go wrongly in 2 ways. They can all go wrongly in 2 ways. Similarly, if there are 4 envelopes and 4 letters, all 4 can go wrongly in 9 ways. You can put n equal to 4. If you put n equal to 4, what happens? This becomes 4 factorial into 1 minus 1 plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. So this gets cancelled. So you'll get this as 4 into 3 minus 4 plus 1. So 12 minus 4. 12 minus 4 is 8. 8 plus 1 is 9. So that is what I wrote. So remember 4. If you want, you can calculate 5 later on. But at least till 4 you should remember. You don't have to write the formula again and again. At least till 4. Now, what does the question here tells us? How do we use this concept in the question? A delivery boy has 10 orders, each of which are to be delivered to different addresses. It's the same thing like 10 letters and 10 envelopes. But we are supposed to do it in such a way that maximum 4 do not get the corresponding orders. Maximum 4, which means what are the possibilities? I can arrange it in such a way that there are 6 wrongs and 6 corrects and 4 wrongs. I can put it in such a way that 7 corrects, 3 wrongs, 8 corrects, 2 wrongs, 9 corrects, 1 wrong, and of course 10 corrects and 0 wrongs. Basically all of them are going correctly, which I should not consider, right? Do not receive their corresponding orders. So that's basically I'm going to look at 10 corrects and 0 wrong. Now let's take a look at, in fact you should consider it, because maximum 4 are wrong means 0 wrong is also considered. Maximum 4 are wrong means 0 wrong is also considered. Now let's go ahead and take a look at how do we get the answer. So if all are supposed to go correctly, if all are supposed to be correctly, only one way. Everything will be placed in their respective envelopes, or everything will be going to their correct orders. Only one way. That's done. Now 9 corrects and 1 wrong. Is it possible to send one letter wrong? Obviously, if one letter is going wrong, the second letter also has to go wrong. For example, if I say these are the 2 letters and these are the 2 envelopes. If this is going wrongly, automatically this corresponding cannot be coming here. So this will have to go here. So you cannot have one thing going wrongly. It will be either 0 things wrong or 2 things wrong. One wrong, exactly one wrong is not possible. So this is 0 ways. Then I am looking at 2 wrongs. 8 corrects and 2 wrongs. Now when I am talking about 8 corrects, first I have to choose which 8 will go correctly. So I will choose 8 of them, 10C8. All these 8 will go correctly. Now, and the remaining 2 should go wrong. How many ways can 2 things go wrong? 2 things can go wrong only in one way. We already saw that. So that can be used directly. Now we are talking about 7 corrects and 3 wrongs. How many ways? First I have to decide which 7 are correct. Because any 7 can be correct. So let me choose 10C7. I am choosing 7 addresses to go correctly. So they will go correctly in one way. So 10C7 ways in which I can choose 7. And the remaining 3 should go all wrong. 3 things going wrongly we already saw can be done in 2 ways. And then finally 6 corrects is 10C6. And all 4, the remaining 4 should go wrongly. That is 9 ways. So the answer is 1 plus 10C8 plus 10C7 into 2 plus 10C6 into 9. So this is 1 plus 10C8 is 10 into 9 by 2 plus 10C7 is 10 into 9 into 8 by 3 into 2. Then there is a 2. And 10C6 is 10 into 9 into 8 into 7 by 4 into 3 into 2 into 9. If you simplify this, we are going to get the answer. So let's quickly simplify this. This is 5 times. 3 goes, so 2 goes, 3 goes 3 times. Then 4 2s are 8, 3 goes 3 times. So this is 1 plus 5 9s are 45 plus 8 3s are 24. 24 into 10 is 240 plus 7 3s are 21. 21 into 9. So 9 1s are 9, 9 2s are 18. 1890. So this is your total value. So let's add them up. 1890 plus 240 plus 45 plus 1. So this is 5 plus 1, 6. 8 plus 9, 17. 8, 10, 11 and 2. So 2176 is your answer. Okay. 2176 is the answer. Therefore, the answer is none of the above. This is a trap. This 2175 you would get if you forget this one. Where is that one coming from? That one is coming from the case where all are going correctly. If you forget that, your answer will be 2175, which is a trap. So the correct answer is none of the above. Right? So this is the concept of dearrangements. Let's move on to the second question. Now, here's a question. It's not a very difficult question. Try to do this in 1 minute 30 seconds again. Your time starts now. So that's 1 minute, another 30 seconds. Okay. Okay, sorry, another 20 seconds, 10 seconds more. Right guys, so that's time up, 90 seconds. Let's go ahead and take a look at it. We have a chessboard which is actually a 8 by 8, but this time you have 15 by 15. So you have smaller squares like this. I'm not drawing the entire chessboard, I'm drawing only few of them. So this is just 15 by 15. So 1, 2, 3, let me put 4 and 5, 4, 5 and so on up to 15. Similarly, you have 1, 2, 3, so on, so forth, up to 15. So that's the chessboard. You have a long, large one. Now, you are choosing only 1 by 1 unit. So look at it. 2 square unit. So how many ways can 2 unit squares? Unit squares means this is called as a unit square. So you are supposed to choose 2 in such a way that there is one side which is common. One side which is common. So you can choose. So let me change the color so that you can follow this. So if I were to, okay, I will use this green. So this will be one, unit. So combination of 2 things. Then I can say this is another combination. Then I can say another combination. So basically 1 and 2 is a combination which will have, there is something common between them. 2 and 3. 3 and 4, like this, I can go up to 14 and 15. So how many such combinations can I have in the first row? In the first row, I will have starting from 1 up to 14. So 14 squares of 2 units total. 1 and 1 together. Total is 2 units. I can choose because any of these I take, there is a line which is common among them. So 14 per row, and I have 15 rows like this horizontally. But that is not it. I can also look at vertical. So if you're looking at vertical, look at this. I can combine this and say this is one piece for me because 1 and 2 vertically there is a common side. Similarly, I can look at 2 and 3, 3 and 4 and so on and so forth. So vertically also I will have 14 and there are 15 columns. So every column 14 of them and there are 15 columns like this. So I can take horizontally or vertically. So the answer is 14 into 15 into 2. 14 into 15 into 2. So 15 2s are 30. So 14 into 30 will give you 420. So the answer is option D. So this is not too much of PNC here. It's more about logic and drawing the diagram correctly. Okay, there's hardly any PNC that has been done in this. Right? Let's move on to the next question. Okay, again, a very nice simple question. 1.5 minutes, 90 seconds. Your time starts now. Very good, Saurabh. That is the correct answer. Let's go ahead and see what is happening here. How many numbers can be formed using all the digits? So if I have to use all the digits, I'm talking about a 5-digit number. Without repetition, when the digits at the units place must be greater than that in the tens place. So units place, if I have B and A, my A should be greater than B. That's all. Here there is no restriction. Now, what I'm going to do here, the logic is very simple yet beautiful. Let's understand the logic here. So what I will do is, I will take any 3 numbers and put them here. I don't care which 3. So which means the first number can be filled up in 5 ways. The second number can be filled up in 4 ways. And the third number can be filled up in 3 ways. Once I fill this, I am left with 2 numbers. Now, among those or between these 2 numbers, there is no possibility for me to choose what to write. Always the bigger number among the left out will go to A and the smaller number will go to B. So these 2 can be filled only in one way. Only in one way, because if there are 2 numbers left, definitely you can see that all the digits are distinct. So if there are 2 digits which are left out, one digit will be greater than the other digit. There is no doubt about it. So the greater digit will always come in the units place and the smaller digit will always come in the tens place. That's it. So if you fill this, then the remaining will not have a choice. There is only one way to do it. So this basically is 5 into 4 into 3, that is 60. It's a very elegant, simple problem if you understand the concept, and this actually is getting into the heart of your PNC. Okay? That's very good, Akhil and Saurabh. That is the correct answer. Let's go ahead and take a look at the next question. Here's the next question, a very nice one once again. This will take a little bit of time for you to calculate, so I'll give you 2 minutes. Your time to solve this is 2 minutes. Your time starts now. That's about a minute. Parth, I will not say my lectures with self-study. Self-study again, I will not say my lectures alone are sufficient. But yes, the lectures that we do, not just mine, my colleagues, any of them, Saral sir is there, Naveen sir is there. There's so many of them who come and do this. We are trying to give out the best we can, but I cannot say that will be sufficient for you, because you need to have a lot of practice on your own. So yeah, it's a self-study part which matters a lot. If you are practicing quite a bit of what we are teaching with a lot of problems for practice, yes, I would say that would be good enough for you. But if you are not able to do that, I would recommend you join one of our courses for either crash course or for the next year, and that would be sufficient. Okay, so guys, that's about 2 minutes. Let's go ahead and see. I got one answer from Saurabh, but he retracted the answer. Let's see what is the correct way to do this. Now here, serendipity. So let me write down this spelling. S-E-R-E-N-D-I-P-I-T-Y. Serendipity basically means an ittifaq in Hindi. It also in English basically means it's a coincidence, a happy coincidence. It's called as serendipity. Now we are supposed to form 4-letter words, 1, 2, 3, 4. And you can see that E is repeating and I is repeating. So there are 2 letters that are repeating. Whenever you have a long word in which some letters are repeating and you want to form a shorter word, You cannot do this directly. First thing you need to understand, there is no direct formula for this. The only way in which you can do this is take the three cases. What are the three cases here? First case is no repetition, no repeat. Second case is only one letter is repeated, only E repeat. And the third case will be only I is repeated. And of course the fourth case will be E and I repeat. These are the four cases that you get. You have to look at the answers for each one of the cases and get your answer. Now, no repeat basically means you have, what are the letters you have without repetition means? S, E, R, N, D, I, P, T, Y. Because the double letters I'm throwing out. Because I don't need repetition. So, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 9, I have to arrange 4 things. How many ways can I do that? This is easy, everybody knows this. 9 things, 4 places, it is 9P4. That's the first case, that's your answer. Second part, only E is repeated. If E is repeated, so we already have 2 E's, right? Now, the remaining 2, because total are 4, I have to choose 2 out of E is gone, so out of 8. So what do I have? I have S, R, N, D, I, P, T, Y. So out of these 8, I have to choose 2. So I will get my group of 4. Now once I get a group of 4, 4 letters in 4 spaces with E repeating, how many ways can I do that? So first let me choose 2, HC2. I am choosing 2 letters which is HC2. Once I chose this HC2 and I combine 2 more E's into it, I have 2, so let's call it as XY, 2 letters, or I'm just, okay, YXY already have some numbers, right? So letters, so let me use them. So I will take SR and let's say EE. So if I use SREE, how many ways can I arrange SREE? It can be done 4 letters with 1 repetition. So that is 4 factorial by 2 factorial. So this is the question where we deal with number of ways of arranging 5 things in 5 places or 4 things in 4 places where repetition happens. All the things are considered, then you get the answer as 4 factorial by 2 factorial, or in general it is n factorial by p factorial, q factorial and r factorial and so on. If there are n letters and there are p things which are repeated, q things that are repeated, r things that are repeated and so on and so forth, then using all the n letters, the number of words that can be formed is given by n factorial by p factorial, q factorial, r factorial. This is the theory behind it. So here you get 8C2 into 4 factorial by 2 factorial. So how much is it? So let me write this down. I will write it down. So let me erase what is not required. So serendipity is gone. Okay, case 1 is 9P4. So let me write it down clearly. 9P4 is case 1. Second case is 8C2 into 4 factorial by 2 factorial. Now E is repeated, that is the answer. Only I is repeated. The logic remains the same, nothing changes. Every calculation remains the same because in place of E, I am bringing in I. So the same thing is happening. So it will be another 8C2 into 4 factorial by 2 factorial. These two will give you the same answers. So you should repeat it. Basically is into 2, or you can write it twice. And then finally 2 E's and 2 I's. So 2 E's and 2 I's. How many ways can I do this? This is 4 factorial by 2 factorial and 2 factorial. This is your full answer. If you expand this and simplify, which I'm not doing right now, you can do it later for practice, you will get the answer as option A, 3702. Okay, that's very good, Akhil. Very nice. I'm happy that you got the answer. At least one of you got the answers. So the correct answer is option A, which is got by breaking this into 4 cases. This is the only way to do this kind of a question. Okay, let's move on to the next question. Number 5. This is a very nice concept called grouping and distribution. So let's do this in 1 minute 30 seconds. 90 seconds that is total. Your time starts now. Alright guys, so that's the end of the time. So what is this concept of grouping and distribution? So what is happening here is 5 different shirts should be given to 3 children such that every child gets at least 1 shirt. So you are basically distributing 5 things into 3 people such that every person gets 1 at least. So the way to look at this kind of a question is you have A, B, C. First, I will look at distributing. What is the number of different things that people can get? So one distribution could be 3, 1, 1. It doesn't matter who gets 3, we'll deal with it later. But the sum, the numbers of shirts is a group of 3, 1 and 1. This is one possibility. Now, what else can be possible? I can also look at 2, 2 and then 1. That is also 5. And you can see that these both are different. Is there a third possibility? Think about it. You will see that these are the only 2 possibilities, 3, 1, 1 and 2, 2, 1. So I have to form a group of 3 shirts. Then the remaining 2 shirts is given individually to the 2 people. Then I have to form, the next case is form 2 groups of 2 shirts. And the remaining shirt will go to 1 person. Okay, that's the idea. So first case, so if I take this 3, 1, 1 case, I will have to first form this group of 3, right? So let me choose 5C3. So 3 shirts I am choosing out of 5. This is the group formed. Now, this group should go to whom? A or B or C. It can go to any one of the 3 people, A or B or C. So this can be sent to any one of the 3 people. And then what else is remaining? You have 2 shirts and 2 people. 2 shirts and 2 people. So 2 shirts and 2 people, how many ways can you make them arrange? So basically that is 2 factorial ways. Because 2 shirts can go to 2 people in 2 ways. So this is the answer to the case of 3, 1, 1. Who will get 3, who will get 1 and what is that 1? Basically is given by 5C3 into 3 into 2. So basically this is 5C3 is 10 into 3 into 2 which is 60. Now let's go ahead and look at the second question. Second question is, or second case, sorry, not question. Second case is 2, 2 and 1. So first let me form a group of 2. So that is 5C2. Once this is done, now I will form the next group. The next group is 3C2. The next group is 3C2. And of course, once I select these 2, the remaining shirt is left out. Now what I will do is these 2. So now it's like this. 2 people I will choose and I will give these 2 groups. Which 2 people should get two shirts each? Which 2 people should get 2 shirts each? I'll have to first choose 2 people. So I will choose 2 people in 3C2 ways. So till now what did I do? I made 2 groups. One group had 2, another group had 2 and I selected 2 people, let's say A and B. Now the question is, this group can go to A or it can go to B. Similarly, this group can go to A or this can go to B. So 2 groups and 2 people, how many ways can I arrange? 2 factorial ways. Once this is done, what else is left for you? So 2 people and 2 groups are done and the remaining 1 shirt will go to the third person who is left out. So there is only 1 way. Now the arrangement is done. So if you multiply this, what will you get? So 5C2 is 10. 3C2 is 3 into 3C2 is 3 into 2. So this is 9, 9 2s are 18. So this is 180. So 180 plus 60, the total should be 240. So please understand here, what am I doing here? I am first grouping 2 shirts, then grouping another 2 shirts. So first I made groups of 2, 2 and 1. Now the question is, this 2 will go to which person? This 2 will go to which person? And of course this 1 will go to which person? So this can be sent in 3 ways. And this can be sent in 2 ways and this 1 will go in 1 ways. 3 into 2 into 1 which is nothing but this. 3C2 into 2 factorial which is the same as 3 into 2 into 1. So this is your final answer for the second part. So 180 plus 60, first part, second part or first case, second case, total should be 240. Right Akhil, so this is not A, not B, it is 240, option D. This concept comes under the heading grouping and selection, grouping and distribution. Okay, it's a very interesting concept and students can make a lot of errors in this kind of a concept. So I have one more question for you in the similar idea. Look at this. What is the correct answer for this? Ayush, 4.5 is not correct. This is very similar to the problem that you just did. 4 fingers, all fingers are different, and 5 rings of different types. So the concept is grouping and then distribution. How do you group and how do you distribute? That's the question. And I'm going to solve this in 2 ways. There are 2 nice approaches for this. I'll give you 1 more minute to think about it. Let me put, just in case, 1 more option called none of these. Now let's see, just to confuse you. Okay, let's go ahead and solve this. So I have 5 rings and 4 fingers. So let's say these are the 4 fingers. Finger A, B, C and D. Now first, how many ways can I give in such a way? So 5 rings of different types can be worn in 4 fingers. Now there's no extra condition given. What could be the extra condition? In the previous question, you had the extra condition that every finger should have at least 1 ring, something like that. Here there is no such condition. So here you can say the first ring can go into any of the 4 fingers. No problem. First finger has 4 ways. Once this is done, that is where the problem comes in. So imagine this is the finger, correct? In a finger, ring 1 up and ring 2 down is different from another finger, the same finger, ring 2 up and ring 1 down. So here, why can't it be 4 power 5? Because the first ring has 4 choices. But when you're looking at the second ring, it can go above the first ring or it can go below the first ring. And it has other fingers also. Hence, it will not be another 4 choices. So the problem here, what you need to understand is if I take these 4 fingers, so 1, 2, 3, 4. Let's say I will take the first ring. The first ring can go anywhere. How many places are there? Ring 1 has 4 ways. Any 4 fingers, directly I'll put it. Let me say I'm putting it here. This is my ring 1. Now, when I'm looking at ring 2, what are the number of possibilities? It can go here, here or here, 3 ways. But when it is going to the finger which has a ring 1, it is not 1 way, it is now 2 ways. It can go up, it can go down. So 1, 1, 1 plus 2 more ways. Here there are 2 ways. So the second will have 5 ways. The second ring will have 5 ways. If you're looking at third ring, again let's understand. Let me draw this once again so that you can look at it better, understand this better. If I'm looking at third ring now, which means already 2 rings are there. 2 rings are already there. So let me say ring 1 is here. Let me say ring 2 is here. It could be like this also. 1, 2, 3, 4 doesn't matter. Ring 1 is here and ring 2 is here. It can be like this also, doesn't matter. Whichever case, doesn't matter. What you'll notice is ring 3 will have 6 ways. How 6 ways? Look at it. 1 way, 1 way, 1 way. 3 ways. And it could be here, here or here. 3 ways. So totally 6 ways. It can be, even if it is like this, you'll still see it is 6 ways. How? 1 way, and 2 ways, and 2 ways. So the third ring, whichever way, whatever happened before it, will always have 6 ways. The third ring will always have 6 ways. And similarly, your fourth ring will always have 7 ways. And your fifth ring will always have 8 ways. So your answer is 4 for the first ring and 5 for the second ring, 6, 7 and 8. So the answer is 4 into 5 into 6 into 7 into 8. This is 5, 6 are 30, 34 are 120 into 56. So clearly none of these are correct. The answer is option E, none, which is what I gave you. And it was not to confuse you. That is the correct answer. These are all traps. These are all traps. Clear? So this is actually a very standard problem of 5 different rings into different fingers, and the way we solved it is the fastest and the smartest way to solve. Okay, so remember these guys, PNC is all about remembering these standard problems, because using these concepts they will build the next question that comes to you. Okay, these are all well-known concepts, well-known problems. These are not new problems. It might be new to you, but somebody who's done PNC thoroughly will see that these are very standard. Any textbook you take, these kind of questions will always be there. Let's move ahead. Okay, now we are going on to probability. So let's take few questions on probability, 1 or 2 questions on probability, and then end the session. There is a question here, not a very difficult one. I'll give you 1 minute, 60 seconds. Let's see if you can get the answer. Alright, so that's about a minute. Let's take a look at it. Amar tells a lie 9 out of 10 times. So probability of truth is 1 by 10. Now the question says he rolled a die and reported that the outcome is a multiple of 3. Find the probability that the output is actually the same as what he had reported. So multiple of 3 means it could be 3 or 6. They are saying find the probability that 3 came and he actually said it is 3, or 6 came and he actually said it is 6. So I want to look at the probability of this. First 3 should come. What is the probability of getting a 3? 1 by 6. And he should say the truth. When 3 came, I should be saying the truth. What is the probability of saying a truth? 1 by 10. Or 6 can come. What is the probability of 6? It is 1 by 6. And when 6 came, he is saying the truth. It is 1/10. So the answer is 1 by 60 plus 1 by 60, which is 1 by 30. Answer option A. A simple probability question. Let's move ahead and take another question on probability. Okay, take a look at this. This is actually a question based on expectation. The concept of expected value. So last question for the day. I'll give you 1 minute 30 seconds for this. Do this, and this is actually one of the CAT questions in the previous years. In the last 5 years, this has come. So your time starts now. Okay, so that's your time up. So that's your 1 minute. This is not a difficult question. This is on the concept of expected value. So when you're playing a game like this, expected value is nothing but probability of event 1 happening into value of event 1 plus probability of second event happening into what happens, what do you get if the second event happens, and so on. This is called as the expected output. So let's first find out the expected output. So when I'm throwing a die, I can get 1, 2, 3, 4, 5, 6. So there are 6 events. What is the probability of getting 1? It is 1 by 6 into. When I get 1, how much money will I get? I'll get double of 1. So double of 1 is 2. Or second event is getting 2. Probability of getting 2 is again 1 by 6. If I get 2, how much money will I get? I will get totally 4 rupees. Plus probability of getting 3 is again 1 by 6. If I get 3, how much money will I make? I will make 6 rupees, and so on. So basically I have 6 such events. So 1 by 6 common, 2 plus 4 plus 6 plus 8 plus 10 plus 12. So this is my expected output. How much is this? 10 plus 20, which is 30, 40, 42. So 42 by 6, which is 7 rupees. So the expected money for me to win is 7 rupees. To play this game, so the whole idea here means if I keep playing this game long number of time, average that I can make per game is 7 rupees. What they're saying is, if he wants a profit of 2, how much can he spend to pay the game? So because it is not just that I'm getting the money, I have to pay something to pay the game. It's at the end of the day, it's a betting game. So I bet some money, I might win something. So if I have to net win 2 rupees, which means I can spend 5 rupees from it. I can spend 5 rupees from it, and over a period of time when I keep playing this, every 5 rupee I spend, I can get 7 rupee back, which means the net effect is 2 rupees profit. Hence, I can afford to spend 5 rupees on such a game. This concept is expected value. Expected value is probability of one event happening into how much money will you get if that happened, plus the second event into how much money you get, and so on and so forth. This is how you calculate the expected value. This is a very simplistic explanation. Actually, when you go to an MBA, when you do statistics, you will have much complicated cases. That's very interesting, but this is the simplest of the case, right? So with that, my friends, we have come to the end of the lecture. I hope you understood the whole idea of this is not exhaustive. I have explained 3-4 concepts at least. We have other sessions coming up where I'll explain other concepts, but I hope you understood the grouping concept, the probability based concepts, the repetition and word selection based concepts. So remember these concepts. We will cover few more concepts in the subsequent session. So stay tuned into our channel on Instagram, YouTube, as well as on our app, and do not forget to write the All India Open Mock. If you are serious about your CAT, you will know your All India performance. Thank you, my friends. See you in the next one.